Thanks for coming out in the afternoon on the very first day of Inforce 2025. I'm Andrew Krug, and I have the privilege of leading the security advocacy and research team at Datadog. We're the team that writes Datadog Security Labs, the Datadog State of Cloud Security, State of DevSecOps, and tons of other great content that you see in the cloud security community. We're around at tons of events like this to hear about how you're thinking about security. So obviously, if you're here to learn more about Datadog, I'm here to catch up with you after the session's over. I can't take any time for questions on stage because it's a silent session, but I'm happy to meet you afterwards. So if you got some time to catch up, we can meet here, or we can meet at the Datadog booth in the expo hall, where I'll be just briefly after this is over. So you're here today to hear about eliminating blind spots in security monitoring. So if you've been in the security space for a long time, you may have started your career working in a data center. Does anybody want to admit to starting their career actually working in a brick and mortar data center? A few. I actually started my career working in a data center full of servers, like actual servers that you could walk up to and touch, running a really old operating system called Novell NetWare. At the beginning of the computing revolution in business, things were a lot simpler than they are now, and the biggest problem was figuring out what size of parka to wear when you walked into the room where the servers were running. A lot of security was physical security. In fact, in the reality that existed back then, a lot of the identity and access management was actually, did you have physical access to the console of that thing? So since then, obviously, things have significantly evolved. The single-purpose siloed systems with manual processes evolved into these increasingly complex, intelligent, data-driven systems that we're all working with today. Today, especially if you're here, you know observability is a foundational component driving much of your decision-making. Whether that's for performance, cost optimization, and of course, security, these are all really, really important in complex cloud-native environments. Also, accelerating digital transformation and user experiences, we have to provide these enhanced feature sets, but also rapidly enable the business to perform tasks that had previously been performed by entire teams of people. That's a really fancy way of saying we're doing a lot more with a lot leaner teams today. So with that complexity and also innovation, there's always blind spots in the strategy to detect and respond. Some of the blind spots that we're going to talk about might surprise you because they might not be things that you're aware of. The good news is that blind spots generally follow a predictable pattern. So I'm a big fan of the notion that like everything old is pretty much new right now, and almost every concern that we have can be addressed by adopting some old tried and true tactics and just applying them to new technology. So to paraphrase a very old expression, the only lesson we learned from history is that humans don't learn from history. And I think today that is probably more true than ever. So if you will join me briefly, it's time to hack to the future by taking a quick walk down memory lane. So if you were around for the 1990s, and I was around for the 1990s, detection was primarily focused on networks. We relied really heavily on signature-based detection, so think file hashes, IP addresses. The incident response process was very manual, very slow, with limited visibility to help us figure out what were actually false positives. So we worked almost every incident like it was a real incident. Monitoring was fragmented across different layers of the stack. One of the most prominent blind spots, though, was actually the silos that existed between the teams, with each distinct team having its own tooling and reporting systems. So application security was not even a term that we used back then, but we had teams of operators that focused on the code that ran. We had network security people and system security people. And the boundaries around their knowledge was so different, they almost didn't speak the same language. In the 2000s, we sort of had the dawn of observability, almost out of necessity. The AWS cloud actually launched in 2010, 5 years after the creation of the first SIEM platform. Applications were just starting to increase in their sprawl and complexity. And if you think about what was going on at this time period, this was kind of the dawn of virtualization. So prior to this, when you wanted to have a new thing, you actually had to lease a pizza box, put it in a rack, and then run that thing. And with VMs, all of a sudden, we started to be able to run more compute on our extra compute. So we had application and server sprawl. The 2010s also brought this era of the very first highly impactful security incidents. It seemed like almost no company, and I don't mean to shame anybody by putting them on this list, this is for the purpose of demonstrating, regardless of company size, no company was really immune to a data breach. On the application side, Kubernetes was released in this time period and forever changed the surface area for cloud-native computing. Datadog was also founded in the 2010s in response to this increasing complexity to help customers address their gaps in visibility that were present in so-called modern applications at the time. And we started to see friction here. And this is something that still really exists today. Anytime that we have brand new technology and technology from the last era of technical innovation, that's going to have some sharp edges where we integrate it. I think the most prominent version of this today is machine-to-machine authentication for agentic AI. But back then, it was where cloud met the data center. We had standards that really didn't work for cloud-native computing that did work for us in the data center, and anytime we saw those two things intersect, we had issues. So today, we're all running workloads in the AWS cloud. That's why you're here at AWS Reinforce. Applications have moved from static to highly dynamic, from simple to complex multi-tier architectures, and have changed fundamentally from generating almost no telemetry to an explosion of data by default. I would say that most people here are probably actually buried in data, but don't necessarily have the systems and the visibility to analyze and act on that data in a meaningful way 100% of the time. So the truth of that is that we're all kind of coping with this data problem. And we have data analysis problems, some of which are being addressed by generative AI. Filtering relevant data to cost optimize what data you're ingesting and acting on from a security perspective is a challenge. And overwhelmed teams that are inundated with false positives will miss critical security alerts often. One of the most common themes in cloud security incidents today is actually we had detection mechanisms in place. They detected the problem, but no one actually looked at the alert and triaged it. So if you look back at the last 5 to 8 years of cloud security incidents, that's an incredibly prominent theme. So in the AWS cloud today, if you're only ingesting the common log sources, you probably have at least 5 out of box. CloudTrail, data plane logs from S3, object access, VPC flow logs, and system logs from compute in the account, and more if you integrate a third-party tool like an identity provider in that logging strategy. The adoption of generative AI has also increased logs exponentially in regulated industries and development environments to detect and respond to AI threats. So just curious from the audience, how many folks are using generative AI? How many people are using logs as the method by which you detect threats in generative AI? Almost nobody. Is anybody actually detecting threats in generative AI? Also, almost nobody. So each one of those logs, including Gen AI logs, comes with its own unique storage format that you have to understand, transform, store, and ultimately use to alert. So we're dealing with a volume of data issue and also a diversity of data issue as an industry that makes detection, response, and triage incredibly challenging. We used to call this the kitchen sink strategy. You create one way for service teams to send logs to your aggregator, and in theory, you check the box and you solve the problem because then it became the detection engineer's problem. The problem with that is that in that increase in volume, there's not just an increase in direct dollar costs, there's also an increased cost in human time to detect, and the confidence and fidelity of those detections suffers the greater the diversity of that volume is. So what we generally hear from folks in the market is that they don't extract a lot of value from their detection and response solution simply because the existing solution are too complex, too noisy, and too costly to cover 100% of their systems. Does anybody identify with that? Like, too complex, too noisy, too costly? Yeah, I see some heads nodding. The biggest problem with building a threat detection strategy on top of SIM only is that you're missing the pieces of critical context that doesn't surface in logs. Some examples of that might be process information, syscalls, kernel activity. In isolation, only logs or only runtime information is just not enough to provide that high fidelity, reliable detection that people can trust 100% of the time. And this is underscored by the need to observe threats and detect them now, today, in these non-deterministic systems like generative AI and agentic AI. So in summary, everybody's dealing with collections challenges, log source challenges, cost challenges, data challenges, investigation issues, and a lack of context from only having logs or only having system context. And while they're dealing with those challenges, they're pressured by the business to deliver more features, protect intellectual property, and make the safety of your consumer job zero, which is more important than ever today as we talk about the rise of generative AI. Quick poll here as well, just to see how broad the problem is. How many people in the audience are in a multi-account AWS organization? Almost everyone. So according to our Datadog State of AWS Security, which is notably a couple of years old now, the most prolific users of organizations use between 10 and 100 total accounts. So 10 being the lower bound, hundreds of accounts being the upper. Collecting data across multi-account, multi-region is often cumbersome and difficult to manage. Has anybody ever collected multi-region, multi-account DNS logs, for example, from Route 53? Yeah, then you know it's like this massive undertaking, like multi-month project, even just to roll out the collectors and then get those all to a central aggregator. So when we talk about that friction in just like getting the logs into the platform, that impacts our ability to do investigations. And investigations often take too long to discover the root cause of the incident. Or worse, if the incident goes back a long time in history, that creates more friction because then you have to backload data from a cold index into a hot index. So in almost every incident timeline, this box in the middle of like, what the heck happened here between our desired state, which is that the shiny new system was working and the system was compromised, what happened in there? We're always trying to answer that. And that window of uncertainty can be quite long, right? The longest incident window I ever worked on was 18 months. And it was a real slog to load all of that data and analyze it, even with today's tools. So that's all to say that just getting the logs into the aggregator is kind of a complex problem. The data formats are a problem, but also the pipelines that we use to plumb logs in these environments also becomes a problem. Because if you're using things like serverless functions to transform data, all of a sudden the proliferation of these things becomes something that you have to actually care and feed. So seemingly simple functions can have a massive impact on the amount of toil that your security team goes through just to transform and ingest logs. So all the standard rules apply here in terms of the care and feeding. So we've identified here, just in this conversation only about logs, a few modern stack blind spots. We have multi-region, multi-account, runtime context, and logs that end up in archives, just to name a few. So you may be asking now, we've kind of like done a survey, flyover at a high level of the problem. What do we do about it? I'm a big fan of making things easy, and at a glance, the notion of that log sync idea, you just throw all your logs at a single thing, does sound good to me, because that sounds like what we call in DevOps paved road. The data transformation is the biggest issue there, and the dollar cost is almost kind of secondary in the context of the things that we're trying to all secure today. And that's where the Open Cybersecurity Schema Framework comes into play, or OCSF. I don't know if anybody's heard of OCSF before today. I know it was a big part of some announcements this week. The OCSF initiative is state-of-the-art in mapping that glut of formats into a standardized schema. And I've seen this try to happen tons of times in my career. This is the most successful effort I have ever seen in terms of just getting every major cloud service provider, every vendor to onboard to this and actually adopt it as their native storage format, not just for ingest, but also for storage. And I'm not sure as a community we quite understand what the impact of that is today. So if you've been around in the biz for a while, you may be equally dubious that this is not going to solve all the problems. But unlike the failed standards that came before this that weren't adopted broadly, OCSF is a taxonomy. So that taxonomy is adaptable based on the type of data source, and it does not just focus on signature-based detections. It focuses on tactics, techniques, and procedures. So we're talking about a schema that was designed for behavior, not for signatures, and that is what has differentiated this. So OCSF is now part of the Linux Foundation, and it's a critical part of how you should be building your modern detection strategy. It's both a format that is supported by AWS and Datadog as a first-class citizen. And what this means for you, if you're doing detection engineering, and just show of hands, how many people are actually doing detection engineering? Quite a few here today. You can write simplified detection rules that will streamline your investigations because now your incident responders only need to know one format that you can correlate across multiple platforms and data sources. To give an example here that's really, really relevant, today your business might have multiple identity providers, multiple sources of truth when it comes to federated authentication. Because if you're an enterprise, for example, you might have acquired a bunch of different companies, and maybe they onboarded with, identity provider 1, and you used identity provider 2. So all of those logs on ingest are mapped to the standard OCSF format via a product like Datadog Observability Pipelines, or what we just call it OP internally. And because that data now exists in a standard format, regardless of the solution, it empowers us to write a single generic rule that now covers all those identity providers. So think about things like account takeover, where you want to do session invalidation or phishing attacks. You don't have to go back and rewrite that rule every time now in order for it to have value as you onboard more log sources. And that's huge. The concept of log routers that transform data definitely isn't new, and there's a variety of solutions in the open and commercial space. The key here, though, is the ease of mapping those attributes, those standard attributes, to the OCSF data structure. So we're going to talk a lot about things that you should be looking for in the solutions that you're adopting to reduce frictions for your team. So that's one of the things that you need to look for, is as I'm onboarding sources that aren't in OCSF, how easy is it for me in the platform I use today to actually map those back to the data structure I'm using to detect? The lower that friction is for your engineering teams, the more data sources they're going to onboard to that pipeline, and the more you're going to increase your threat coverage. An additional bonus of using a log router is the ability to migrate tools, adopt tools, and filter data easily. That agility allows you to pick the best tool for the process, and you can move your logs, if you choose to, even from one SIEM to another with a ton of agility, which partially addresses the cost component in successfully implementing any SIEM solution. So before today, before OCSF, moving out of one SIEM and into another was a multi-year project. And in fact, sometimes it would double or triple your cost because you were replicating data to multiple data sources while you train your team. And we just don't have to do that anymore in 2025. Data retention becomes an additional potential concern. So one example of this is from government. Not sure if we have any public sector folks here. Memorandum M2131, it's one we like to talk about a lot on stage that affects government contractors and agencies. This requirement dictates that you have to retain logs for a minimum of 30 months in a lot of use cases. Can you imagine retaining 30 months worth of logs for your business if you're not in government for 30 months in a hot index, and what the impact would be to you? Or even just searching all those logs in the event that you had an incident. So this is where Datadog and AWS come together to provide a better long-term retention option. So this is a definite better together story. AWS Security Lake, if anybody's familiar with this, was one of the first partnerships that we launched. We actually launched it at AWS Reinforce. Security Lake supports OCSF as the native storage format. And it can be the intake for events as well if you fall into that category where you have these very long data retention windows that are required of your business. Push of a button, up to 7 years retention in Security Lake. Security Lake also makes it incredibly simple to ingest, aggregate, store, and filter logs before you send them along to Datadog. It's also very, very simple to onboard multi-account, multi-region to Security Lake if you do fall into that long-term retention use case. So for companies with a little bit shorter retention requirement, Datadog Cloud SIEM now offers this thing called Flex Logs, which is something a lot of customers ask for the retention and archival of logs as they age out of the system to more cost-effective storage tiers. And this is a big deal, right? Because you don't necessarily want to have the logs unavailable or have friction in the event that you have to reload them, but you do want to store them in a little cheaper tier so that in the event that you do have an incident, it's easy to recall those, but they're not just sitting there costing you a ton of money on the shelf. That's just one piece of the puzzle, though. So we've solved like data ingest, data transformation, storage format, retention in 2 use cases. Our additional detection sensors we're going to discuss today that I firmly believe that you can't afford to live without come in the form of what we call non-traditional security data. So the first is runtime security. And if you see me this year, I'm talking about runtime security a lot, trying to raise awareness for all of the different types of runtime security you can have in your environment and how it benefits your detection strategy. So runtime security can be really challenging to talk about because for years we've only talked about this as file integrity monitoring. So some people map runtime security to the concept of an EDR or something like that. And while those things do runtime security, runtime context provides far more visibility than simply changes in files. So we're becoming aware of this with the rise of Gen AI, but before this, we also had other runtime security sensors. The first of which is the Datadog Security Agent. So it's a part of the product line that we call Cloud Security Management now. We call it Workload Protection in the UI today. The Runtime Security Agent collects a variety of data points like process telemetry, syscall data, network, memory. For example, if a piece of malware attempts to change a user password on disk, we could easily detect that via logs. However, what we would be missing was the initial access vector and the knowledge of whether that came through an exploit or what the parent process was that actually executed that. So we have all this rich context that we can use to almost reason at the edge about the criticality of alerts just from changing this one setting in the Datadog agent. The workload protection agent detects threats that would otherwise take incredibly large volumes of logs or context to bring to light quickly and effectively. It gives you additional critical insight you can use to open an investigation or take an action. So that's like a pretty cool additional value add. One feature you should always look for as you're thinking about runtime security is the ability to activate and deactivate which sensors and rules are firing on that runtime security telemetry. So as we think about moving beyond simple things like file integrity monitoring to more complex attack chain style behaviors, we need the ability to kind of be agile and play with that as we tune it for the business. The Datadog Workload Protection Agent allows you to do just that using our supported tooling in a safe and secure manner. Workload security today supports Windows, Linux, Kubernetes, and Fargate workloads to give you complete insight regardless of what you're building in the AWS cloud. All right, so that's two blind spots we just discussed and solutions. Another potential is actually the data from what is going on in the application runtime. Depending on the stack, whether it's precompiled bytecode, dynamic code, or just in time like C# or the JVM, something in your stack has runtime context from the language itself. And this is an area we're actively trying to raise awareness for in the security community, because for us, this is all built on top of Datadog application performance monitoring. So is anybody familiar with APM? A lot of security people aren't. So for years, operations teams have used tracing data to optimize performance. That's simply a span of the information regarding the amount of time it takes to make calls between services like a database or a web server and a REST API. Turns out a lot of that data is super, super useful for understanding security context. And today we're actually, as a community, doubling down on that with things like the Open Telemetry project, which are adding these schemas to more and more things beyond application runtime like generative AI. We can use that context to create security signals. So this is the product family that's called Datadog App and API Protection, which works by matching signatures to traces. So it's effectively a set of heuristics that operate on HTTP headers to detect threats that previously wouldn't have been detected. Thanks to runtime context, this can reliably identify things like SQL injection, local file inclusion, server-side request forgery, and then it adds that, if you want, to a global block list. So the first time this happens to a single instance from an attacker, that IP or that user entity is going to go in a global block list that then is blocked across the entire fleet that's serving that application. You can decide whether that's permanent or penalty box. There's a lot of knobs to turn. The more you use a feature like that, the better the benefits, because again, the block list is global. It turns your entire fleet of public attack surface into a network of sensors that generate that block list. The interesting thing about using the concept of tracing here is the tracing concept is extendable to almost anything. So think about it, right? We're detecting the round trip time between services or the round trip time in a call to a database. And if we think about a new technology that we can apply an old method of problem solving to, it's generative AI. Because the reasoning graph for Gen AI actually to us looks an awful lot like an APM span. And that's where LLM observability comes in. It's a Datadog product that was released last year, seen rapid adoption due to its ability to understand activity in these non-deterministic systems like LLMs, using the same principles that we applied to tracing. And actually, what's on screen here is a generative AI generated diagram of how this tactic benefits security. It's not just inside of Datadog. This is also a standard that's evolving in the Open Telemetry community, and it has very real practical applications in the way that you think about detecting and acting on generative AI threats. So the approach reliably combines all the pillars that we've been talking about today, which are safety, security, and performance, to provide visibility into what goes on from the time a model is prompted to the time that that model returns its answer or artifact. Today, it can detect things like prompt injection, indirect privilege escalation, user toxicity, and hallucinations. So this is just one more example of how runtime security can help you eliminate blind spots in your organization. And I know the screenshot here on the slide doesn't do it justice, so if you're interested in seeing this, I would encourage you to stop by the Datadog booth and have a deep dive into this demo, because the product has actually evolved a ton just in the last couple weeks, and we're really excited to show it to you. So some key takeaways here before we wrap the session and then we go to hallway track for questions and answers and networking. Key takeaway one is observability has been a foundation for operations teams. It is absolutely a pillar of security. and that's something that AWS and Datadog are 100% aligned on. Runtime security is most definitely on the rise in all the different forms that you just saw in this deck, plus a few more, and it should definitely be a part of your security strategy today. So if you're looking to reduce toil and increase the signal and reduce the noise, runtime security is one of the best ways that you can add context to the way that you're assessing the criticality of an alert. The third is that runtime security does not replace the logging strategy, right? Logs are still an essential foundation to what you're doing, and having a great SIEM platform is effectively table stakes now. The thing that you can do to benefit yourselves the most, of course, in that logging strategy is just like us, just like AWS, really encourage partners, applications, vendors like us to adopt OCSF, because that just benefits everyone in the way that we write detection rules. It eliminates things like vendor lock-in, increases log portability, etc. So with that, I'm going to wrap here. I have a couple of quick QR links on screen here today. One is to sign up for a free trial of Datadog, which I'm sure you've seen the link before. The other is that we just launched a brand new community-focused security newsletter this year, and I'd love to have you subscribe to it. The content, believe it or not, is actually written by a human being. In fact, we're so proud that the content for this newsletter is written by a human being, we actually put the name of the human that wrote it at the top of the newsletter. So if you're interested in getting practitioner-focused content from my team and the internal research team at Datadog, visit that link on screen and subscribe to the newsletter. And with that, I thank you for being here on the first day of Reinforce in the afternoon, and hope to see you in the hall.